Hello, good morning, afternoon, whatever time it might be. It's morning for me. Hi, it's Friday, it's the coding train. I have something exciting to show you really quickly. What's that? Well, oh wait, it's all zoomed in. Why is it all zoomed in? Anyway, how are you? Is my mic on? My mic is on, the music is playing. I am so excited for today's live stream because I have a plan. I've thought about it. I'm not exactly prepared, but I spent some time on the subway doing some reading and watching some videos to think about what it is I'm going to do today. And the first thing that I'm going to do has to do with this box of toothpicks. What could possibly be on the coding train related to a box of toothpicks? You might be asking. Well, soon I will tell you. First, let me do some housekeeping here. And talk to you about what's happening for the rest of the year on this YouTube channel that you are watching. So there are only 2 more live streams in 2018, both of which are happening next week, and then I will be off for quite a while until January. So I believe here, if I go to website youtube.com/thecodingtrain, I will see first that I am streaming live, and then I want to show you these 2 things. So 2 things are set for next week. On Monday at about 3 p.m. Eastern Time, I will be coming to you live from not this room, but from about 5 floors down. On the 4th floor is the program called ITP. That's the graduate program. The undergraduate program is called IMA. These are both programs at Tisch School of the Arts at New York University. The end of the semester show is coming. Over 100 projects made by an incredible set of talented students from all over the world. So I'm going to walk around with my phone and somebody to help me and interview students and show projects. So you can tune in for that. If you miss it, don't worry, it will all be archived, and I also will produce probably, the whole live stream will probably be about 2 hours, but typically after that's done, I produce about a 20-minute kind of like edited compilation highlight reel of a bunch of the projects. By the way, if you have any live streaming, and you might have some tips for me. I'm looking into currently getting, I have a gimbal, I have a person who's going to help me hold the camera, I have a variety of different microphones that I'm looking at using, but I'm looking at getting one of those kits for a mic that goes with the camera and a handheld thing and all that sort of stuff. So if anybody has any experience or some things you want to suggest that I could get between now and Monday, let me know. Then, coming to you next Thursday, at about 10:30 a.m. in the morning, I will be doing my annual Processing Foundation Holiday Telethon. And by annual, I mean a second annual. I did it last year. Sort of spur of the moment last year. I'm a little bit more planned this year, although I don't actually have any topics in mind, but I am looking for you to suggest stuff. So let's move over here for a second. If I go to, and I want to come back to this in a second, but if I go to, I don't want to import my bookmarks, go away, whatever. If I go to github.com/website/rainbow topics, I think I need to rename this repo, even though, coding train /rainbow topics. This is a repository where I kind of keep a list of suggestions of things that I might do in a video or on a live stream. And currently, there are 877 open things. And look at this! Suggested 4 days ago, toothpick patterns. Toothpicks. Nice, not a sponsor. I'm going to do the toothpick challenge today. But I'm thinking what I would like to do is add a label. I'll go to labels. I'm going to create a new label. I'm going to call it Holiday Telethon. Probably should be some red-ish or green. Oh, I like that green. I can't, hold on. We'll get there eventually. That's not really very, that's good. That's very dark. But Holiday Telethon label, so I'm looking for holiday-themed coding challenge ideas. For example, one that I will most likely do next week is the Koch snowflake, which looks like any of these patterns. Whoa, I've never seen it done like this. So we're going to have to figure that out. So this is something like things that are wintry, holiday-themed. That's my plan for next week. Hey, startup guy, thank you for the super chat from India. The other thing I'm trying to get working, but I don't believe that I'm going to get it unlocked, unfortunately. YouTube has a feature called Super Chat for Good, which is a way of sending super chat donations directly to a nonprofit 501c3 organization, of which the Processing Foundation is one. So I've been in contact with YouTube to see if I can get that enabled for my account for next Thursday, but I don't know if that's going to be possible. So just to be aware, I'll be asking people if you are able to make your donation through processingfoundation.org/support. But anyway, that'll be next Thursday. Abiljit Maji in the chat asks, you really came up with this video after Smarter Every Day? Yes. So I mean, I had the honor, was lucky to get to actually meet Destin at ThinkerCon, which was a conference that he organized a little while back in Huntsville, Alabama, and I've been obsessively tuned into his channel ever since. And the Fourier Series video. I mean, I also want to show and reference the 3 Blue 1 Brown series on Fourier Series, which is also excellent and something that I had tuned into quite a while ago and rewatched. So I want to get started with that. Simon Tiger is saying I'm pronouncing Koch wrong. I know. I know I'm pronouncing it wrong. But sometimes in life, we just have to pronounce things wrong to get through the day. Okay, now. And Smarter Every Day just said hello in the chat. What up, Fourier peeps? Okay, so this is what I'm looking for next week, your holiday-themed coding ideas. I have purchased a new ukulele. I purchased a new ukulele, which if you can stomach your way through about an hour from now, if you're still actually watching, or 2 hours from now, I might actually unbox. I hear unboxing is like a thing. I'm of a mind, I'm just gonna like forget this coding thing and just make unboxing ukulele videos, but we'll see. I'm gonna open up my new ukulele and try it out because I will be singing very badly next Thursday coding-themed holiday songs. This is really a terrible idea. But, as you donate to the wonderful nonprofit, the Processing Foundation. So I'm also looking, in addition to suggestions for holiday-themed coding challenges, I am looking for your lyric submissions of holiday music with coding lyrics. And I had a bunch of them from last year. Thank you to Emso-me, who wrote a whole bunch of those. All right, so that's what I have to say. Now, one thing I want to do is I want to briefly, before I get started with the first coding challenge, I want to show some of the projects that the community has made. So I'm going to go to the coding train here. The most recent coding challenge I did was this flocking simulation. And I was recently speaking with Nikki Case, who is one of my absolute favorite internet artists ever. If you do not know the work of Nikki Case, you should check their work out. But Nikki Case reminded me, Explorable's website. I hope this is going to come up. Yep, here we go. Explorable explanations. Look at that! Does anybody recognize that? Those are Boyd's right there on the Explorable Explanations website. So if you want to know how to code this Boyd's algorithm, you can go right here and watch the flocking simulation one. Now, I'm going to go to this page here, and we have a couple, we have a bunch of submissions from the community. So as you know, as you might not know, but if you watch one of my coding challenges that make your own version of it, you can submit it over here. So I want to click through these. There was also one that isn't submitted here but came through the comments. I'll have to dig it up and find it. Somebody made a flocking simulation in Unity, which kind of like blew my mind. So before I get started with the coding challenge, let's take a look at a few of these. So I'm going to go here. This one I love, and I'm going to go to the full view of it. What this one is here is the Tasteful Toasty, love these internet names, took my flocking coding challenge and combined it with my quad tree coding challenge. This definitely gets a horn. I'm really like a person in their 40s who has a train whistle on the internet. Okay, but so what this combination is, one of the things you might notice if I go to just my actual coding challenge, let's actually, oh shoot, see it live. No, view code web editor, that's what I want to do. So I'm going to run this, and I'm going to add, this is 200 Boyds. Thank you, Daniel Astillero, for the super chat. I always feel also awkward about these super chats, but thank you. That is really, really nice of you. I appreciate that. Okay, so what I want to show here is, see how there are 200 Boyds flocking right now. If I increase this to even just like 500, look how slow that's running. This is because every single Boyd has to check every other Boyd in relation to where it is. If you watch the coding challenge, that's what I went through. How do these Boyds move according to their neighbors? This is incredibly slow. If you can do the math, 500 check Boyds, each one checking every other 500 is 500 times 500, which is some number that I could get the answer to on a calculator or in my head, but it's too stressful when you're live streaming. And if I made this 1,000, look at that, it can barely go. Now this is not a limit of a computer to draw, right? If I comment out this line, look at this, the computer has no problem drawing 1,000 circles. Quadratic complexity, thank you. I always say exponential, which is absolutely wrong. It is quadratic, thank you. And so here, now if I go back to this, what this is doing is it's using a quad tree algorithm. What is a quad tree? It's a way of sectioning a computer graphics window or any two-dimensional space. You can have an octree in three-dimensional space into various buckets. And all of the Boyds register themselves in particular buckets. And then when it's time to look at the neighbors, it doesn't have to look at everyone. It can look at just the ones that are within its bucket. And this is called quad tree optimization. It sounds very fancy, but it's not that. It's a thing you can do. You can actually, it's called quad tree because you can actually keep subdividing based on how many Boyds are in any particular area, but you could also just do what's called spatial subdivision. Like we could just divide the screen into equal parts, and that would also work well for flocking. Now, if I go back to the code and I change this, look, that's already 500. Let's change this to 1,000. You can see like, okay, it's not running super fast. That's because there's still a lot of stuff for it to do, and this is JavaScript in the browser, but this is a reasonable animation with 1,000, which is really wild. And there's probably a lot of like further optimizations you could do. Like there's tons of stuff in my code where I'm doing all these extra square root calculations and that type of thing. Okay, so I am going to, sorry, I'm distracted by multiple chats going on. I'm going to just change this back to 500, which is a nice number for us to see. Look how fluid and fast it is. Great. So thank you, Tasteful Toasty, for doing this. So I'm going to leave now. I'm going to go back to, where was I here to find the other ones? Where? The internet is a hard thing. There we go. Let's look at colorful regular polygons flocking by Juan Carlos. And let's click on that. This I love to see. So a couple things about this I love. One is a nice new interface that's quite a bit more nicely designed with actual labels to play with the different rules. And then, a lovely design take on this, instead of just using circles, to use different polygons with different colors. Wonderful work. Let's move on to 3D. I'm afraid. Does this involve quaternions? 3D Boyds with quad tree. And then let's look at this one. Let's actually, once again, I want to go. One of the things I think would be nice to add to this web editor is a button that immediately gets me to the full screen view. But I can just type it into the address bar. So this is really cool to see. So this is actually now, I wonder, is this using the WebGL renderer of P5? Amazing if it is, and you can see this is happening in 3D. We can decrease the number of Boyds, increase them, change their perception, bump up the separation. So many fun things. I encourage you to play around with this on your own. Then we've got Evolution Aquarium. Oh, Oh, I saw this. I think someone sent it to me on Twitter or like posted it in a comment. I don't know exactly how this is working, but this is like my dream project. If you ever have seen the Nature of Code book, the sort of like working exercise through that whole book is to make your own ecosystem with a lot of different agents that are have different rules and are evolving different behaviors, and this looks like it is a manifestation of that. Smarter Every Day is still in the chat, says, oh dang, I was hoping for 3D. The 3D is coming. I'm going to find that Unity one, which is really wild. So what I love about this is each one of these creatures, now I haven't looked at the code, I don't know what's going on here. I actually think it would be, in this kind of case, I would love for the creator of this maybe to consider a write-up about how all this is working. But there are predators, there are avoiders, there's food, there's poison, and there's creatures, and you can see that everything is, that I imagine this is also built on top, in addition to the flocking behaviors, using my genetic algorithm evolutionary series to evolve different behaviors. What I love about this is I can click on show names, and they all have names, like Sweet or Daisy. I just love that. Like, where do these names come from? Maybe they could use some kind of like text generation neural network thing to like generate names for all these creatures. And then I can do things like add a predator. I think that's spelled incorrectly. I'll pull request that. I'll pull request that. Predator. So I think if I click now, oh, so the red are the predators. So I could get distracted with playing with this all day. I think I want to feed them. Okay, so and I could feed them. Look, they're eating the food. Look at that. I can drop little bits of food. Oh, these kind of projects get me so excited. So I really want to like play around with this and explore the code and kind of understand what it's doing, but I'm going to set that aside. So I was planning on starting with the Toothpicks. That was going to be my warm-up because I have to admit, I checked out this book from the Courant library, which is the like math computer science library here at NYU, called Fourier Analysis. I was all excited. I was like, I'm going to go get a math book. I left it downstairs. I want to have it here as a prop. I'm going to read it on the subway. And then I started looking at it. I was like, oh dear. This is a little bit beyond. But so I have two things I want to do. One is the Fourier Series, and one is the Toothpick Challenge. I don't know. I was planning to do the Toothpick Challenge first, but now I'm thinking maybe I should start with the Fourier Series. I could always just go, oh, the Unity thing. One more 3D. So I'm going to find this video. And yeah, sure, you can show me notifications. I am going to find the Unity. Can I find a comment? Where is it? Somebody commented and linked to their Unity version. Maybe somebody watching can find this more quickly than me. Unity. Seriously? I just thought, okay, I could find this. Hold on. Is it not? Maybe it wasn't on this video. Let me find it on this computer I have to the side. Shoot. Here, let me play some awkward waiting music. Oh, how come I don't hear the music? Oh, All right, let me try. If anybody in the chat can find, yeah, I was trying Command F. That can find this comment, recent comment. I'm going to go into my YouTube studio over here. The URL was an itch.io. I'm going to go to community. I have a second computer here if you're wondering what's going on. And I'm going to go to look for itch.io. In honor of, here it is. I found it. Okay. oxrock.itch.io/flocking voids. Okay, here we go. Here is someone, oxrock2k1 on YouTube, writes, I created a 3D implementation with blue jays, and I love birds. I'm like I want to be birder. I have one of those life books. You know what the life book is, where you write down every single bird you've ever seen? I travel. I know I've talked about this. I traveled to Norway, to Runda Bird Island to see the puffins, which I didn't see, but I had an amazing time there. I won't rehash that story of going to Norway. But allow you to adjust relevant values in real time. You can play it here. Link. I also posted the scripts on GitHub for any who are interested. I will bring it's github.com/oxrock/boids. But let's run this. And see, I do not know how to program in Unity. It's something I have always wanted to explore. But I love the fact that there's this actual like bird flapping 3D model animation. I don't know how well this is reading. One thing I would love everybody who watches my videos to always be conscientious of is contrast ratio. This is a really important thing to consider when you're making content on the web for accessibility. People with low vision cannot necessarily read text that is not high contrast, and there are certain web accessibility standards that would be good to follow. So anyway, I'm not sure if you can see this, but you can see there's bird count, separation distance, cohesion, alignment, momentum, and settings. So anyway, I would play around with this. You can add a lot more birds, but I encourage you to check this out on your own. It is really interesting to see this play out in 3D. Daniel asks in the chat, is Unity only for C#? Is Unity only for C#? I think C# is the programming language of Unity. You can also program apparently in JavaScript in Unity, but I don't think anybody does. Wonderful. So thank you for this to Oxrock. This was really exciting to see. It kind of makes me think about wanting to try a little Unity. And also, I still want to put this out there. Anybody who wants to try, no one tried this, I don't think. I'm going to go here, view, rule, flake. Yes. So I mentioned this, that in the book, The Computational Beauty of Nature, which is a MIT Press by Gary Flake describes a fourth rule for flocking. View. Move laterally away from any void that blocks the view. And the theory here is that if the voids, in addition to the alignment, separation, and cohesion rules, are also trying to keep their view clear, they might actually end up in the kind of pattern you typically see of birds in the sky, that V pattern. That pattern emerges without a leader through the local interactions between those birds. Okay, so let's go to Schiffman.net randomizer. No, it's not that. Schiffman.github.io. Let's put in Toothpick Fourier. Let's submit these. Let's spin the wheel. Okay, everyone. Speaking of accessibility, I really need to work on this spinner. Look, it's very like holiday themed today. Okay, here we go. Which one will I do? Oh, it's gonna stop before it gets all the way through this, I'm pretty sure. Oh, do I really have to do the Fourier series first? I really want to do the Toothpicks series. I even rigged up an overhead camera, which is no longer on. Oh, wait. There we go. I even rigged up an overhead camera. Hello, everybody. These are my nose hairs. Whoa, that made me a little bit dizzy, actually, to be perfectly honest. All right, I guess we're starting with Fourier series. All right, so I need to get myself set up a little bit. And so first let's pull up a bunch of links. Smart Every Day. This video. Let's pull up, actually, let's go to Doga's blog, which is in Turkish, but there's actually, Doga has a post which was translated into English. How am I going to find this? Twitter. I think, so what I'm doing right now, just so you know, is trying to find all the resources that I use to make sure I credit things properly. Billy, blah, 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 blah. Okay, hold on. I just want to, there we go. I'm pretty sure that's the Twitter handle. And then, yep. And then somewhere in here is a post, translated to English. So great, we're going to do this. We're going to come down here to look at this. Okay. Then we are going to also go to 3 blue, 1 brown, Fourier. This video is really remarkable. If you have not watched, but what is, oh, I forgot that this is still on. Move the overhead. I'm so sorry. I didn't realize that was there. If you have not watched this, but what is the Fourier transform? So when I make an edited version of this as like a short coding challenge video, I will probably reference to watch this and the Smarter Everyday video first, because I'm essentially like the way that my channel works, if you haven't watched it before, Destin, is that I try to do that sort of like last step implementation. Sometimes I know exactly how the math works and I can explain that. Sometimes I'm relying on somebody else's derivation or proof of a formula and I'm just figuring out how to make it work. But I want to show the entire process from start to finish of creating this visualization. Even if we don't understand every interim step, we can understand every line of code. So that's what, but this is really a remarkable explanation of the Fourier transform. There's also actually a really nice, better explained Fourier. I was looking at this also, is excellent, an interactive guide to the Fourier transform. And so now I think I can close out all these other things. And then I'm going to do this in the P5 web editor. I think this can work in the, this I think is, I mean, there's nothing simple about what I'm going to do. It's very hard. I had a really hard time thinking about this and trying this out this week. But I think it's a smallish amount of code. What is the password? Oh, no, it's just coding train. That's why. It's a smallish amount of code that I think I can do it in this editor so that there's an online version that you can find. Oh, and then, of course, we would not be able to live without Wikipedia. No, Fourier Series I want. Fourier Series, yep, here we go. All right, and so one of the things that I love, but okay, here we go, oops. Did I lose the better explained? I've got this. I've got, so Wikipedia. I've got the blog post. I've got the 3 blue, 1 browns video. Let's get this somewhere as I reference it. There's like a mind-blowing part of this to me. And there's so many mind-blowing parts to this video. I've watched this video probably almost like over 10 times. And also we can move this to like, just like this would be good. Like, look at this, the mechanical, see this is, I wish I could do stuff like this, build mechanical things. Someday we can dream. Okay, so this, I've got the code thing here. I'm gonna put that here. Oh, better explain, I lost the better explained. I don't know why. One of the things I love about this page is this. Smoothie to recipe. So I was trying to come up with my own metaphor to explain what a Fourier transform can do. And then I read, oh, that's really good. Although maybe I shouldn't use it, I should come up with my own, but I'm gonna use this and credit it. Okay. All right, so how's everybody doing? Everybody ready for this? Let's get the whiteboard going. Oops. Next time I live stream, maybe I might remember to actually erase the whiteboard before I use it. This, by the way, is a book of Christmas songs for the ukulele that I just got delivered to me yesterday from Amazon. I also have this keyboard, but that's what I used last year. But oh, and there's the eraser. Wonderful. Okay, so this was my diagram of the flocking stuff. Woo. Let me erase that. I have so many good toothpick shtick ideas, dropping them all on the floor. There were going to be lots. I had all these plans. And the Fourier series is gonna make my head hurt. Okay, erase, 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 erase. Let's make sure I have a working marker. Hello, I'm over here. And Fourier, let's write this. Fourier, le Fourier. No, I'm not going to write transform. I'm going to say Fourier series. All these are interrelated terms. And it definitely gets some like hearts and like a little rainbow for Fourier. Maybe like some stars. There we go. Okay. How are we doing? All right. Can you tell that I'm procrastinating, that I'm like terrified and don't want to try this? All right. Here we go. Okay. Toothpicks. Just think of the possibilities. I will have to first read some random numbers. Let's see here. No. I don't know. Oh no, that's the. It's going to help me relax. Before I get started with the Fourier series, I will be reading from a million random digits with 100,000 normal deviates. If you were waiting for me to actually do some coding, I'm so sorry. Page 165. 4,289, 25,108, 89,176, 88,185, 52,361, 665, 785, 7,626, 5,479, and 91,144. Okay. I think that helped. CC Gauche writes in the chat, I'm French and you don't pronounce Fourier correctly. Okay, sorry. I'm totally game for a lesson on pronouncing Fourier correctly in French. All right. Let's get started. Actually doing some coding. So let's call this okay. All right. Here we go. How's this font size? Can people see this font size okay? I think this is going to be a fine size for the canvas. Wait, why? What is going on? It's weird. There we go. Okay, something weird happened for a second. Oh, whoops. Let me do this. I think it's actually better for me to just increase the font size this way. My computer is really acting up. And then have a larger canvas to work with. And then give myself a little more space. Okay. Fourier, is that better? What is going on this computer? Let me just, this makes me nervous. Hold on. Just make sure things are working. Yep, all right, we're fine. I'm having a little panic attack. Okay. Ah, what? Did you not just see that change? I just hit Command S. And it changed. What is going on? All right, I gotta just, we're gonna code this in a second, but I'm having a little bit of a panic here. Let me close this. I have a feeling that this page, not this page, but this page is running a lot of real-time JavaScript-y stuff. And so I wonder if that is causing problems. Yeah. The editor, I wonder if I need to like move away from the editor because some weird stuff is happening. Okay. All right. Something weird is going on, but let me just bear with me for one more second. Okay. All right. It's not getting the last thing I say. You know, something got fixed. So I'm going to not use the web editor right now. I'm just going to actually use a Visual Studio Code. I think this might. I'm sorry to like go off topic yet again. I really will be starting this in a second. But I'm just going to point this out. I have a feeling that there's issue 675. Yes, I have issue numbers memorized. This is a bug in the web editor that the leave site dialog shows even after you save your work. And this was just fixed within the last 18 hours. And I think there's like something, maybe something that this fixed like broke something else. So I am going to, what I'm going to do, this will take me just another couple minutes. So apologies. I could also just do this in processing, but I think I want to do this in JavaScript for a couple of reasons. So what I'm going to do is just give me a second here. Actually, even better, what am I doing? I'll just take this. Come on. There we go. So if you're wondering what I'm doing, you can check out all my workflow videos, which show how I work and create these projects. Whoops. Oop. So we're going to use, oh, right. Okay, now I'm ready. Sorry for that little pause thing, but now we are ready. This is actually a nice, oh, you know what I'm going to start with is this, because this is basically exactly what I'm going to recreate. So I will have this open here. Beam, I don't know how to pronounce that, which is the problem. Okay, let me cycle the cameras again. We're really getting started now, everybody. Okay. You know what? I'm going to do this. Yes. Okay. All right. So just so you know, this is basically exactly what I am about to program. And I'm going to get started right now. Let me just open this computer back up in case there's any emergency messages. Okay. Stretch. Hello, welcome to a coding challenge, Fourier Series. So what I am going to program in JavaScript using the P5.js library is exactly this. This is what's known as a Fourier series. It is a series of wave patterns that when summed up together approximate some other function. What does that even mean? So first of all, I'm going to show you some resources, the things that got me thinking about this topic and wanting to make this coding challenge. And you probably should, if you want, stop this video and go look at these other resources, and then you can come back if you want, or maybe you're just off doing something else. So pretty recently, Smarter Every Day came out with a video called What is a Fourier Series? Explained by drawing circles. This video reminded me of an amazing video that I had watched at some point in the past, I guess like almost a year ago, called What is the Fourier Transform? A Visual Introduction. You've probably, if you've done any coding and programming, you've probably heard these terms before. FFT, Fast Fourier Transform. It's usually referenced in the context of analyzing sound. And so Smarter Every Day's video was a collaboration, worked with a Turkish researcher on this website here. I'm not going to attempt to pronounce it. I will. bilimnezguzilan.net. I encourage you to check out and read this whole article. But this is a visualization, again, of exactly what I want to do. A series of wave patterns visualized as a path along a circle, periodic functions summed together to approximate a square wave. And if we can make this happen in JavaScript, then there, in theory, is no reason why we couldn't then figure out how to draw any given path as a series of Fourier transforms. And there's like a sort of well-known GIF or video of this like crazy set of circles drawing Homer Simpson. So I'm hoping to get there, but this video, I just want to, by the end of this video, have exactly this pattern in JavaScript. Okay, so I also want to reference this website, betterexplained.com, which has a nice article, an interactive guide to the Fourier transform. And this, I think, is a really excellent explanation. So again, I'm going to start coding in a second, but you're just going to have to humor me to let me kind of talk about this a little bit more, just to get my feet under me here. So the idea of a Fourier transform, so a sound wave, right? We have this idea of a sine wave. You've probably seen me draw sine waves on the board or in code in countless videos, usually drawn something like this. A sine wave has a frequency, which is how often does it repeat? Like if this is the sort of x-axis, like this is one whole cycle, right? And I could think of that as like the time it takes for this circle to this dot to go all the way around the circle. So frequency is like how many cycles of the wave per unit of time, like per second or per frame. There's also amplitude. Amplitude is the height of the sine wave. How much distance between the very top and the very bottom. And so a sound, a pure sound, a tone, the musical note, I meant to hit A, but I hit G. And that was, I don't have anywhere close to perfect pitch, so who knows what note I just sung. We can get the ML5 machine learning pitch detection model to tell us. That's another story for another time. Can be represented as a sine wave. So, but you probably have seen like, oh, I've got this recording device soundy thingy, and what it's doing is it's like, this is like the sound, this is the wave, this is the representation of the sound that I'm listening to right now. Well, you can create, this kind of wave pattern is typically actually the sum of multiple wave patterns. Can be represented. This wave pattern, so in other words, if this is like the musical note A, and then this is like the musical note something else, and we're to add these two waves together, can you still see where I'm drawing? You know, I might get something that looks like this. Right? And I've done this, I think I have like an additive wave video in the Nature of Code series about this kind of idea. The idea of the Fourier transform is, can we go, right? I could have these two waves I could add them together and get this pattern. Could I go in reverse? If I'm listening to a sound like this, could I pull out all of the waves, the sounds, the frequencies that make up that? That's like pitch detection. Or if I wanted to then filter out a very high-pitched sound, if I could take the sound, break it apart, take away one of the high-pitched sound, add it back together, I would get this. So this is akin to, I love this metaphor here in the Better Explained, of unsmoothieing a smoothie. So I like to make smoothies, actually, little known fact. I was like, anyway, so, but could you, like, right, let's say I take some mango and some kale and some blueberries and some like almond milk and I mix them all together and I give it to my children and I say, I made you this beautiful smoothie. Can you guess what's inside of it? This is actually a game we actually play at home. I'm just realizing, so this is perfect. Well, if I could do a Fourier transform, I could take the mixed smoothie and filter out, go in reverse and find out all the ingredients. That's the idea. So that's the idea of a Fourier transform. That's conceptually what it is. Now, what I want to do in this video is I'm not going to worry about figuring any of this out. Now I understand what it is, what it can be used for. I have this goal eventually of having it, using a Fourier series to draw any arbitrary path. But one way to get started with that is exactly what's demonstrated here on this website, which is what waves do you need to add up together to end up with a square wave? And you can see here, this is actually a really nice visualization as you have more and more iterations of the Fourier series, how it converges even closer and closer to this square wave. I can also just go here to Wikipedia and find this again. So this is the clue. So there's this idea in a Fourier series of Fourier coefficients and some kind of like iterative thing of like n and n plus 1 and n plus 2, and we can actually see a nice clue to that in here. This is actually this is one of the simplest Fourier series. What is the series? 1, 3, 5, 7. Can you guess the next number? 9, right? And what's after that? 11. So if I could just implement this, each one of these circles and like have them rotate around like this at that period or frequency with that amplitude, we're going to get somewhere. So I've talked about this for way too long. Let's try to actually code this now. All right, so the first thing that I'm going to do is, where's my code? Here it is. Here it is. Okay. So the first thing that I want to do, I'm just going to start, like kind of even not thinking about the Fourier series, and I'm just going to make up a variable called angle. You can really think of that as time. It might be more appropriate for me to call this time, because time is moving forward. That's a sort of crucial idea. And then I'm just going to say time equals, every time through draw, if you haven't, sorry, let me make this a little bigger. That's too big. If you haven't worked with P5 before, draw is a function that loops over and over again, So time is moving forward. Then what I want to also do is I just want to like draw a circle somewhere. So I'm going to translate to like 200 pixels over and 200 pixels down. I'm going to have this idea of a radius. Like the radius of a circle that I want to draw is maybe going to be 50 pixels. And then I'm going to say ellipse at 0, 0 with that radius times 2, because the ellipse function expects a diameter. Radius is half that. I'm going to make this white. So I'm going to say stroke 250. Stroke 255. Somebody told me how to get rid of that autocomplete, and I still haven't done it. And no fill. So when I go back to the browser and refresh it, I've got a nice circle there. Let's make it a little bigger. All right, so now what I want to do is, how can I have that dot traveling around the circle? Let me have the dot traveling around the circle. So the way that I would do that is I would use a polar to Cartesian coordinate transformation. And I certainly have a video that talks about how to do that. But what I'm talking about here is, if this is the radius, and this is the angle, which is really in my program the time, how far over in x and how far over in y can be calculated, how far up in y can be calculated based on trigonometry. So the radius times cosine of the angle, or angle is the x value. The radius times sine of the angle is the y value. So I'm going to do that here. I'm going to say let x equal radius times cosine of time, and let y equal radius times sine of time. I should probably pause and turn that off. But let me get through this first. Point x, I'm definitely going to pause and turn this off. Point xy, I'm going to say stroke 255, stroke, actually let's make this a circle also. So we're going to say like ellipse xy, we're just going to make it smaller, like 8 pixels. And let's also say fill 255. Oh my God, this is making me crazy. And here we go. Look at that. There's that circle moving, right? That circle is moving, and maybe it makes sense to also draw a line from 0, 0 to xy. And now I've got this, and I want it to move a little bit faster. And honestly, I'd like it to go the other direction. I'm not sure. I should actually check. What is it doing? If I want to like recreate exactly what's here, yeah, it's moving the other direction. So I've got the beginnings of this. Now, I haven't worried about the number 4 here and the fact that I've got the angle divided by pi, but we'll get there. OK. I'm going to pause for a second. This will get, when I release this as an edited video, this will get edited out. Let me try to find. OK, so also Amr makes a good point. Writes in the chat, I am using Fourier series and Fourier transform interchangeably, but they are not the same thing. That is absolutely correct. It's not my intention to use them interchangeably. Let me see. So first thing I want to do is figure out how to, does somebody in the chat know how to turn off that autocomplete that's making me crazy? And then maybe I will try to give a statement to clarify the difference. So hold on. How do I turn off Visual Studio Code autocomplete? Simply press escape. All right. Second, you can disable it in the VS Tool settings. Requires a restart of Visual Studio to take effect. Thank you, Smarter Every Day, for the super chat. That's very kind, unnecessary, but kind. Did I miss any? I should really make sure I didn't miss anyone else. So hold on. Let's just turn it off completely for right now. Visual Code Studio Tools. Auto-complete. JavaScript. Well, I guess I'm just going to turn this off right now. I like tab completions, but let me just turn this off. OK. Now, still doing it. Let's see if a restart of Visual Studio Code was what the doctor ordered. No! Ah! This, by the way, is what programming really is. The instructions do not match the behavior. Let's actually, this is on like the Unity website. Someone's got to know. Oh, editor accepts suggestion on commit character false. OK, thank you. I am so me. Let's try. By the way, so Visual Studio Code, this is a bit of an aside. If I go to Preferences, Settings, this is like the interface for changing the settings. Thank you, Numedu Mosa. What I'm going to do, first of all, it's very nice that people are super chatting me. I think I have a way of checking all of these later. You should wait, hold your donations till next week when I'm doing my fundraiser. OK. Open settings.json. You can also actually just edit the settings through here. And I'm going to try what I am so me suggested, which is editor. Ooh, look at this. This is when I want the autocomplete. Thank you very much. Oops. I need more space here to see this. Editor dot accept. Now it went away. Fine. Accept suggestions. I have this JavaScript.suggest enabled as false. That's interesting. Suggestion on commit character false, comma, goes here, and curly bracket. OK. Let's just restart Visual Studio Code one more time. It's not as bad now. Oh, it's just giving me like, this is better. It's actually giving me like P5 things. Oh, it'll bring up the suggestions. It just won't fill it in when you do. All right, that's fine. That's fine. The nice thing is here, for some reason it was giving me crazy stuff, but now it's actually giving me P5 suggestions. Like, that's what I want. All right, I think we're going to move on. Let's also install this, update whatever it is. Okay, all right. Yeah, it looks like it's only pulling stuff that's in the current file, which is, as far as I'm concerned, great. And I lost my cap to this marker. All right. So let's try to, before I get back into the coding, I think maybe I should also clarify Fourier series versus Fourier transform. Oh, yes. Fourier series is for periodic signals, and a Fourier transform is for aperiodic signals. Fourier series is used to decompose signals into basis elements, while Fourier transforms are used to analyze signal in another domain. Okay, so I think I'm going to point, hopefully this is a good answer. That makes sense to me. And you can see here, periodic function by a discrete sum of complement with Fourier is used to represent a general non-periodic function. Right. So, okay. So let me just bring this up really quickly so that so I don't confuse people who are watching the video later. Okay. I'm back. I fixed this autocomplete thing that was bothering me in Visual Studio Code. I'll put something in the description about how I did that. But I also wanted to mention in the chat, thank you to Amr who wrote, you are using Fourier series and Fourier transform interchangeably, but they are not the same thing. So thank you so much for that comment. Applause. I don't know if you can hear that. There's like a presentation going on out there and people just started applauding. Just when I said, definitely don't applaud for me. So I will post some links also in the video's description for more reading about this. But in short, the Fourier series is for periodic signals, which is what I'm doing exactly right now to create this square wave, which is periodic, versus the Fourier transform, which is for aperiodic signals. Another way of thinking about that is to represent any general non-periodic function. So hopefully as I get further down this road, I will come back to this. But, and also in the chat, Smarter Everyday writes, Fourier transform is for swapping between frequency domain and time domain, which is also a really nice way of putting it. Okay, but what I am doing in this video is implementing the Fourier series, the periodic series of that add up together to this square wave pattern. Okay, all right, let's get back to the code. So here we go. So I have success step 1. I have my circle passing around. And you know what? I think that I probably should. I think that I probably should not put this. I'm going to have it go I should. Wait a second. Yeah. I'm going to have this not go the correct direction. I'm going to have it go this, because I don't know if the negative number is going to mess things up there. Okay. All right, next thing that I need to do, and if we go back to this particular video, is how can I take this circle that's moving around and then draw the resulting wave pattern? And this is actually kind of a much simpler problem than you might think, because basically what I want to do, this is moving in 2 dimensions. X is oscillating back and forth, Y is oscillating back and forth, and both of those oscillating at the same frequency with the same amplitude in the same phase, the starting together, is moving along the path of the circle. So I just need to take the y value and sort of graph that along the x-axis. So the way that I'm going to do that is I'm going to add an array to my code. I'll call it wave. And it's going to be an empty array. It has nothing in it. And what I'm going to do here is every time I calculate a new y value, I'm going to say wave push y. So I'm just going to save that particular y value. So now all I need to do is say, for let x, I'm not going to use x, I equals 0, I is less than wave.length, I plus plus. Let's draw a point at I comma wave index I. Right? So all I'm doing here is saying, let's just draw all of those height values, those y values, from kind of x equals 0 to as many of them as I get. So if I do this, you're going to see, look at that. There's that wave pattern going. All of those points are moving up and down. And you can see how the height of that wave is the same as the thing passing around. Okay, but this doesn't look so great. So what I want to do is I want to instead use begin shape and end shape. This will and then say vertex. So this will actually like tie it all together. And I think if I say no, it's actually I'm gonna leave the fill in there for a second because it's kind of cool. So that's actually like trying to fill in the shape, which is a sort of a nice pattern. But I'm gonna just say no fill. I'm gonna do this, refresh the page, and then also, why not translate, just to translate this a little bit over, like 200 pixels. And we can see this. And then I guess I could also draw a line. Would this make sense? A line from x minus 200. This is weird what I'm doing now, to the first point. Wait, there's people. Time out for a second. What am I doing here? I just like thinking, what do I want it visually to do? Let's look at this Wikipedia thing. Yes, sorry, I want to draw a line. Yes, I want to draw, sorry, I got confused what I was doing. I want the end of the line to connect to where that is. Oh, of course, okay. So what I want to do is draw a line. So I need that first, I need this first value. So I have x minus 200 comma y to I comma wave index 0. And actually it's not I, it's 0. So this is just, this I know is the very first point in this loop. And since I translate it over, I've got to like back up with my x value. This is very awkward. Oh, no. I don't want it to connect to here. What am I doing wrong? Why is what I'm doing different? Oh, I'm doing it backwards. I know what I'm doing. I'm doing it backwards. I actually don't want to, I'm appending to the end of the array. So every new value I'm appending to the end, I want to add it to the beginning. So instead of using push, there we go. Instead of using push, I want to use unshift. So unshift is a JavaScript function. It's a weird name for it, but push just adds this thing to the end of the array. I want to add it to the beginning. Oh, that was a mistake. There we go. This is what I'm looking for. There we go. Okay. So now I have the line connected there. Now, one thing that's a little bit of an issue here is that I'm just like adding points and adding points and adding points and adding points and never getting rid of any points. So I also should probably, at some point, I should say something like, if wave.length is greater than, like, I'm just going to make up some number right now. I could do a calculation of how many points I need till the end of the canvas, but just to move more quickly here, I'm going to say wave.pop. So that would just like, if it's getting more than 500, it's going to like delete the last one off the end. And now we should be able to say like, I should be able to look at wave.length. It's 152. So clearly I only need like, I don't need more than 250. So let's redo that again. And we'll get like 250 points. You can see it's, here we go. I just want to make sure it stops at 250. Yeah. There we go. So it stopped at 250. Okay. How are we doing? Okay. Sorry. I need a second. A little water. All right. Let me think what the next step is. All right. Okay. All right. All right. Okay. Coming back. Let me cycle the camera while I'm taking a minute here. Okay. There's a lot of noise going on in the hallway. All right, we are at this spot. Now comes the exciting part. I mean, this was hopefully all somewhat exciting, but to me, how do I suddenly go from I have one circle with a point around it to another circle that's kind of like there with another point around it, to another circle that's like there with another point around it. How am I going to add up these circles and continue this path of x, y along them with all of these points rotating and spinning? And guess what? I've actually done this before. I'm just remembering now. I have a video on the fractal spirograph. Let's see if this comes up. Yeah, the fractal spirograph, I actually did this already in the fractal spirograph, which was this way of doing exactly this to create a fractal pattern. I should go back and revisit this. So we'll see if how this compares to that. So let me go back to the code here. And so what I want to do, so first of all, before I do this, I think I need to think a bit more formally about these functions. So before I was just saying radius cosine of time, radius sine of time. But these functions actually map to these values on Wikipedia here. So if theta is my time, basically, what I'm saying is that I want to, and the value multiplied by that is 4 divided by, sorry, theta is my time, and 4 divided by pi is basically my radius in a way here. I'm kind of conflating some things, but I can start to use this particular series to understand the ratio of the radii and the frequencies between these different oscillating circles. Okay, so let's say, what I do is I say 4 divided by pi times cosine of, what was it again? 1 times time. So I'm going to do this. I'm going to just change the y here. And then what I'm going to do is I'm also then going to say radius times that. And also, I missed something. 4 divided by what? 1 times, this is confusing because there's a 1 here. 1 times angle, 1 times pi. So I'm going to say and that's 1 times time, and this is 1 times pi, and this is 1 times pi. So the number that I need to change for each circle is that 1. So let's just see what this actually yields. And I'm going to go back to here. It's the same thing, but now the fact that I had that radius was 100, it's like everything is way too big. So what I'm going to do is I'm going to change this. Is really more like a scaling factor at this point. I'm going to change this to 20. And now we can see, whoa, boy, that's still really, let's just change this to 10. There, that looks better. And then what I need to do here is this number here. So I'm going to say, really what I should be saying is this. Hold on. This is going to get calculated here. I will refactor this later. Let's put this in here. And then let's make this back to this, because I don't really need, let's make this back to here. Okay, and 4 times divided, this should be 1 times pi. Why is it doing that to me? I don't want that far. I want these divided by each other. Visual Studio Code is too smart for my own good. There we go. There we go. That's what I wanted. That's why it was giving me something crazy. Anyway, okay. Radius is not defined. Sure it is. Where? Radius. This is the point. The circle. Now I need to draw the circle next. This is when things are going awry. And let me put this here. There we go. And now, there we go. Of course, now it's this time. Of course, I had the division in the wrong place. I have this tiny little wave. So let's go back and make that about 25, which I think would be now basically like, oh, but it's divided by pi. Ah! This is going remarkably well. There we go. Okay, I'm happy where I am now. Okay, so now I have that first circle. The reason why I am doing this, the reason why I'm putting this, making all this work, because I want this to be n. I actually want this to be a number that changes, right? First it's 1, then it's 3, then it's 5, then it's 7. That's not too hard to figure out, right? And what I want is to start x with and y both at 0 and just add this stuff together. So x plus equal, x, y plus equal. So I want to, and then what I want to do is I want to loop n. So n is going to go from 1, I'm going to say 0 actually. N, because you got to count starting with 0. N is less than 2, n plus plus. And then, and this really, by the way, I should call this I, because what I'm really saying is, n is, how do I do 1, 3? I mean, this is pretty easy. I multiply by 2 and add 1. N equals I times 2 plus 1, right? When I is 0, I get 1. When I is 1, I get 3. When I is 2, I get 5. So now if we add these together, and I'm just doing 2 right now, and speaking of which, I should move this all the way down to here. And I'm going to take this out for a second. And then I got to go back here. And there we go. Okay, so something is wrong. I kind of got things close. Like, look at this interesting, weird, crazy pattern that I've got. Blah. What is going on? So I definitely messed something up. But let's see if we can figure that out. Okay, so the line should not be going from, so I should be actually keeping track of previous x is x and previous y is y. So I'm going to like take out the wave for a second because I'm going to have to change what I'm doing here. And then I'm going to just say previous x equals x. Oh no. And then previous x equals x, previous y equals y, and then the line is going from those. Like it's not always going from 0, 0, it's going from the previous xy. So now that's right. The other circle also needs to have its center be at previous x, previous y. And there we go. So now I have this. I have this circle spinning around this circle, spinning around this circle. There's only 2 circles. But in theory, if I change this to like 5, there we go. Now we're getting somewhere. And actually, it would be sort of fun. I really think that I should think about how I'm drawing this a little bit better. So for example, I think I want these circles to be much lighter. So let me give them a little alpha. And then the points should also be, I think the points are almost like less relevant. I almost don't want to draw these points. Let's just, because I have the lines now. So let's see what happens if I take this out and I do this. Oops. But I want the line to be full brightness. There we go. So this is what I'm looking to draw. So there we go. So I now have this particular series with every circle next to rotating around every other circle. And I am using the values from the particular Fourier series for a square wave. Okay, so now, and I feel like this should be bigger. It's so small. Let's go back to having this be 100. And let's actually not, let's just see how this looks. And we can also, I'm being like neurotically silly about, let's move it over a little bit. Okay. Oh, I don't want it to go off the screen though. So let's leave it there. Split the difference, 75. Okay, and then I have to go back a little bit. This is very silly what I'm doing. Okay, there, I have a problem, 150. There we go, okay. So I know this is hard for you to see, let me zoom in on it. So this is where we go. So now, guess what? We're basically done. right? Before, I just had to put the wave back. Let's see what happens if I just put that wave back. Like, what happens? If I put it back, well, what's going on? Like, I'm getting some crazy thing here. I don't even know what's going on. So what I need to do, what clearly is happening is I am not getting the correct y values and drawing it to the correct place. So I've got to fix that. Even though I like this interesting pattern, I've got to fix that if I want that square wave. You can sort of see the square wave pattern here. So what I want to do here is, oh, I'm pushing all the values. I just want to push the last value. Actually, this is going to be a much easier fix, I think. I just want to push the last value after the loop is over. And there we can see, there we go. But I don't know why this isn't shifted over. Did I lose that somewhere? Yes. So this, I need to do this. This is actually going to be, all of this was actually fine. And there we go. We are done. This is the Fourier series for a square wave in JavaScript, programmed in about, oh, I'm not visualizing the middle line. This is a good point. Well, I don't know if that's what Smarter Everyday is asking in the chat. But I should add one more thing to this, because this is going to become relevant later in my mind's eye of how I'm going to do more videos on this. So right now I am visualizing the resulting wave pattern. Also, I got to do a few more things. Will you please bear with me? I know this video is already about 70,000 hours long, but let's at least add one slider. And I'm going to use the, and so I'm going to have a slider that gives me values between 1 and 10, and I'm going to start it at 1. And what I'm going to do is I'm going to take a slider.value. So basically, I'm going to have n be slider dot, I'm going to have n control the amount of iterations of the Fourier series itself. So now you can see there's just 1, so I can use this slider to add 2, 3, 4, 5, 6, and this is 10. And this is fun that I can actually do this in real time. So now you, the viewers of this video, will have so many more creative and interesting ideas about how to make this prettier, how to create more interactivity. There's so many, but this is just an inkling, right? Every system that you build with code has a bunch of variables and parameters. There's no reason why you couldn't make those interactive. You couldn't even, like, we could make the number of iterations mapped to a sine wave itself. Like, what would happen there? That would be crazy. But now you can see up to 10, we can see how it's converging. And I don't know how far I want to push this. Let's push it a little. Let's try. Let's put it at 100. And that's 0, all the way up to 100. Performance-wise, it's fine. It's happy to do 100. There we go. Look at this. Look at that square wave. Oh, that is like the nicest square wave I've ever seen. This is making me so happy. I cannot explain to you. I feel like this is a thing that's been in my head for years, but I've never actually sat down to program it. Of course, I am standing right now, but close enough. All right, so one more thing that I want to do. I would really like to also see this path here. I would like to trace out the path of what this endpoint is doing, not mapped to only the x value, but also the y value. So the way that I might do that is I might say, let path, another array. This is, I think, going to be a little bit easier. And I'm going to say path dot push. This I can add to the end. And I'm going to use create vector because I need to store both an x and a y. So in the wave, I only needed the y value because the x values are fixed. With the path, I need both the x and the y value because I want a visual of that path. We'll see how high we can get it to go in JavaScript before my computer explodes. Okay, so that now what I should be doing is, and then I just need another one of these thingies. By the way, that's the technical term for this thingy. So I want to do another loop. I want to do it actually before I translate. And I want to just, instead I'm going to do path.length, and I'm going to say path index I dot x and path index I dot y. Ah! Okay, is this right? My brain is starting to melt. Oh yeah, there we go. Look, it's drawing the path of the circle. I move it up to 1, now it's drawing that path. Now, of course, it's like drawing over itself a million times. So every time it cycles past 2 pi, I should reset it. What's going on here? Time, n times time. Oh, but when n is 1, that's 1 full cycle. This is a little bit silly, but I'm going to say if time is greater than 2 pi, just reset the path to nothing, and then reset time back to 0. I'm sure a more thoughtful way to do this, but let's just see if that works. Like it's drawing the path, and then we're not going to really see it clear. Yeah, it cleared. Right. So that's exactly what I want. And then now, if I do a couple iterations, we can see, and this is sort of crazy what it's doing. Like I'm seeing it draw that path. It's draw that path. I need more space. I need more pixels, Mozart. Let's give myself. I should end this video. Okay, so I'm going to stop here. I'm going to do some more during this live. This is so confusing to explain. Thank you for watching this coding challenge. I'm still going to be here after I stop talking in a second. And that's, yeah, you'll edit this, right? Okay. Hold on, let me just put this back to something reasonable. All right. Thank you for watching this coding challenge visualization of the Fourier series for making a square wave. Check this video's description for a link to the Coding Train webpage with this challenge and the code for it. And then if you make your own variation of this, please share it with me. You can contribute it right there. So what are some things you might do? Number one is, why don't you try doing this sawtooth wave? Could you take the code that I wrote and make it do this? That would be a nice exercise to try. What other kinds of interactivity can you add to this in terms of changing the colors, changing the different parameters, changing the view of it? What happens if you do this like in 3D? Like, right? Could you have like some kind of like point oscillating over 3 dimensions in a sphere and then map that to something? That would be cool. So I look forward to seeing what kinds of things you create, ask your questions and all that nonsense. I mean, it's not nonsense. It is not, I mean, whatever. Goodbye. See you next time. All right, that was just my end of the video thing for when this gets edited. I feel like there's like a lot of new viewers I'm getting the sense of, so I'm trying to explain my weird process, but I'm not doing that well at all. So let's see how far we can push this. So first of all, let me give myself a little bit more. All right, I need to save a snapshot of this. But I am going to, I'm trying to think of what I want to do. And then I want to do the toothpick challenge. What time is it? Ooh, it's noon. Oh, that took a long time. It's going to be a really long video. Okay. I need I plus equals 2, not I plus plus, says Alka. Oh, you all are having a chat about something else in there. All right. So let's see. Let me give myself a little bit more space here. And really what I need is more width. And I should, if I'm really thinking about this, I should have everything be relative to like the size of the window, but I'm not going to program that right now. Let's just try putting this up to like 500 and see what happens. Oh, I lost the, and then let's translate this over like a bit more. This should obviously be a variable. There we go. Okay. So we're going to give this a try. We're going to see like how JavaScript performs as I move this up. And maybe what I should also do, I should probably like console log what the number is, but that's fine. There, that's 500. What is... Something is like very weird. But I'll take it. I just want to, I want to turn off the... I wonder if I did something with the path incorrectly. That's confusing me. Let's turn that off. There we go. Let's push it up to 500. Hello to Consult Keith Young. Apparently, welcome to all the new viewers. Dan, you could have the user be able to change the Riemann function. Yes, I could. All right, this is crazy. All right, make the first circle set to phi. Try to make a 4 pi limit. People are giving me all these amazing suggestions. I'm going to move on. I think it's time to do the toothpick. I want to do at least 2 things today. Plus, I said I was going to unbox my ukulele. So I think I'm going to leave this at where it is. And I'm going to move on and do the toothpick challenge. Thank you, everybody. Make the path fade. Yeah, I'm going to do the, you know what? I'll do the toothpicks in processing. Because people have been clamoring for processing. And since I'm having trouble with the P5 web editor anyway, I will have to use array list, which is always really awkward, but that's fine. Okay, so I'm going to close out all this stuff. I am going to put this back to what it was. This is what it was. I'm going to make this like, let's do this. Okay, there we go. This is good. Okay, so I'm going to leave the code like this. Look for, all right, so people are asking, what did I mean by Homer Simpson? So my goal, my new goal in life is to be able to, if I Google Fourier Series and Fourier transform maybe, there we go. Amazing how things work, is to recreate this. And I'm just going to skip ahead pretty far here, but you can see, look at this. This is using, like, basically doing exactly what I did, but on this completely arbitrary path of Homer Simpson drawing. Like this, like, makes my mind, and so if you watch the Smarter Everyday video, what Doga did is to, what Doga did was recreate the Smarter Everyday logo. So I suppose I would love to, in JavaScript, maybe recreate, I don't know, this, something, a rainbow, this cloud, something like that. One of these characters, something like that. So that's what I'm going to do. Can we take a break? Daniel asked, can we take a break before the toothpick? Yes, because I also need to go get some more water. So I'll probably take a few minute break. And so actually, so one of the things I really want to do is create some, I need a video that I can play while I'm taking a break that's like, be right back. But I am going to right now just go toothpick, number file. Let's go here. Let's find a nice, that's good. And then I also want to go here. And I want to go where? Here. Here. Okay. This is, by the way, quite possibly my favorite website in the entire world. Look for Homer Simpson cycloid from Santiago. Let me see if I can, there's a way that I, look for Homer Simpson cycloid from Santiago Ginobili, writes with a super chat, Vitor Nogueira. There's a way that I can see all of the super chats, I think through an interface that I have here. Let me just try this. I think if I go here, no, that's for me to give myself a super chat. Somewhere I saw that there's like a way that I can have a page. Actually, by next week, if I could get the super chat for good thing, I want to have something, I want to program some stuff where like a little thing would happen when there's a super chat, if it's a donation to the Processing Foundation. I can't find it. I don't know how YouTube works, but if I go here, no, here, nope. I can't find it. I can't find it. So I apologize if I've missed people's super chats. I can definitely see them later. And yes, I'm using the invisible computer. That's where I look at your chat. and also the Slack channel that's going for Patreons. You should do it with drawings from the quick draw data because they already give you the right path inputs, says Me I Am Subi. This I should do for next week. So quick draw data set. What's the most holiday-y thing in the quick draw data set? Is it maybe like snowman, I'm guessing? I forgot what the... So yes, so let's work on that, coding train enthusiasts. Let's try to figure out a way to do that. The quick draw data set is great. Thank you, AJ3600. Okay. Wolfram Alpha can give you a formula to draw images too. Interesting. That's interesting. Okay. So I'm going to do the toothpick patterns, which is here and here. Here, I want to A139250. A139350, is that what it was? A139250, search. That's this sequence. So I want this sequence, which is this sequence, which is this. Okay, this is, and then let's do this in processing. So processing is a Java-based program environment, very similar to P5 and JavaScript, but it's a downloadable desktop thingamabob. This is my vocabulary. As it gets closer to lunchtime, my vocabulary really starts to fade. It's not good. Never attempt complicated, fractal, recursive coding challenges before lunch. All right, so I'm going to take a short break. I know people like the this dot song. As always, I always forget the this dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do dot, this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget the this dot, this dot, this dot, this dot, this dot song. This dot, this dot. Never forget this dot. This is a high-tech solution. This dot, I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do dot, this dot, this dot, this dot. I am so good with technology. This dot, this dot, this dot. I'm going to do this. Okay. This dot, I'm going to do this dot, this dot, this dot, this dot. I'll put on something else for you. This dot, never forget this dot. All right, I'm about to mute my microphone, and I will be back in about 5 minutes. Okay, I'm back. How was that? Was that longer than 5 minutes? It is time. Oops, overhead camera. That was about 10 minutes. Oh, there we go. Yeah. There we go. Okay. One more coding challenge for today. And then, where did I put my eraser? There it is. All right. Okay, so toothpicks. 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 Okay. This one's gonna. I'm really excited about this. I don't have a plan for what's going on here. Ah! All right. Maybe pouring all the toothpicks out wasn't the right idea. Where? Oh no, over here more? Yeah. Wait, oh no, here. And then, okay. All right, so. All right. Let's try this a little bit ourselves. So I'm going to try as best I can to make this toothpick pattern that I learned about from this number file video. Oh, you can't see that. Wait, hold on. I'm on here? Okay. Wait, what if I do this? I don't know. This is not going very well. There. So the idea here this is just like when we played the universal paperclips game on the coding train. Okay, here we go. Just want to see how I am so mechanically challenged. It is so sad. I will definitely be able to, ironically, program this faster than I could possibly make the toothpick pattern. Let's just try to, I'm going to try to fill up at least the space that you can see. So where do I need to add some? Definitely one would go here. One would go here. Yes, you are now watching a live stream of a person arranging toothpicks on a desk. I think I've run out of space. I guess I could go up here, right? Because there's still more that you're seeing. Oh, it's zoomed in again. Every time, does the camera oh, you know what it is? The camera, look at this. Could it be just the weight, that the fact that the camera is pointed down and mounted, that the gravity is actually zooming it back out, zooming it in? Is that what's going on? It's like, why is there no space for my toothpick? My toothpicks. I wasn't doing this in the right order now. Okay, I give up. Okay. There's like a Rain Man joke in here somewhere too, I think. But okay. It didn't zoom in. It didn't? What's going on? Is it just like slowly over time? Yeah. Like if I pull it down, it zooms in. If I, yeah, I don't know what's going on. Gravity is a thing. Okay. Anyway, this is not really that relevant. So first of all, welcome new viewers. Apparently, I don't know how many people are watching right now, but I seem to have a lot of new viewers. Thank you. I am a person who wastes a lot of time on a live stream that's supposed to be about programming, I guess. But really, it's just about a lot of nonsense around toothpicks and random numbers and brain melting out of ear things. And so here we are. So I am now going to attempt to do a coding challenge to implement this particular visualization of the toothpick pattern as demonstrated in this recent number file video. We will be using this online encyclopedia of integer sequences by N.J.A. Sloan, who is featured in the video. This is the particular sequence that I'm looking for, I think. Is this A192350? A192, oh no, 3. A1, that's the wrong one. Let me copy it. A139250. A1, oh boy. This is not the right one. A139250. Totally on the wrong toothpick sequence. There we go. So if I do my programming correctly, I should get the sequence of numbers. Here we go. Here we go. Okay. Here we go. Stretch. Everybody stretch. Always important to stretch when you're programming. Oh, I'm going to hurt myself there. Okay. Hello and welcome to a coding challenge. Toothpicks? I know, this is a little weird. What I'm really doing a coding challenge about toothpicks, and in fact, I have all these toothpicks on my desk over here, and I thought, oh, I'm gonna have this really amazing video where I arrange them, and I can't. I'm terrible at this sort of thing. So but I do have an overhead camera, which is exciting. There's some possibilities there. So what is this toothpick pattern? Terrific toothpick pattern. So first of all, I would suggest, pause this video right now, go and watch this wonderful number file video which explains the toothpick pattern. And you can use it to generate interesting fractal-like visualizations in a two-dimensional space. This actually comes from the research of N.J.A. Sloan, who is the founder of my absolute favorite website. I mean, I don't know. There's other wonderful websites, so I don't know. I don't want to play favorites here. But the online encyclopedia of integer sequences is a pretty awesome website. It's just a website of sequences of numbers. And I've used it before, and there's so many things to explore in terms of these sequences of numbers. But one of these, a particular sequence of numbers, comes out of this toothpick sequence, Omar Pohl's toothpick sequence. So this is a nice interactive demonstration of the toothpick sequence. You start with, oh, wait, we can do this. You start with a single toothpick, and then you say next, and you put two toothpicks. I can zoom in on that. Two toothpicks. I'm doing it. I'm making content with multiple cameras. You put two toothpicks like this on the ends, and then you say next. And I also put toothpicks on the ends. But the next step is the key step. So once I get to here and I say next again, notice how no toothpick goes here, right? Toothpicks can only go on what's called a free edge, an edge that's not touching any other toothpicks. So this is touching here, this is touching here. I can actually point over this way. I don't know. I don't know the best way to do this. Let's get rid of that camera shot. And then if I keep hitting next, look at this. I keep going and going and going and going and going and going, and I can adjust the scale, and I could actually just say run and boom. So I want to make this in the processing programming environment, which is a Java-based programming environment, can I make this? So a couple things. One is this is fun to play around with. You can play with different parameters. You can render out to a PDF. And in addition, what's going on here? Why is this a number sequence? What's kind of fascinating about this, and if you watch the number file videos, can you create an equation, a formula, to sum all the given toothpicks at any stage of iteration? And that's exactly what this particular number sequence is, which I will now do a dramatic reading of because I like to read number sequences. 0, 1, 3, 7, 11, 15, 23, 35, 43, 47, 55, 67, 79, 95, 123, 155, 171, 175, 183, 195, 207, 223, 251, 283, 303, 319, 347, 383, 423, 483, 571, 651, 683, 687, 695, 707, 719, 735, 763, 795, 815, 831, 859, 895. Okay, that's good enough. Let's start coding. So the first thing that I think I want to, let me save this, call it Toothpicks. Let me make sure, let me minimize some of this other nonsense that I'm not using, move this over here. Let me make a window that's 600 by 600. Let me draw a background that is white, and let me hit run, and we can see, there it is. There's my window. This is where I need to draw the toothpicks. So I think what I want to do is, skip a few steps here. Like I might, if I'm really trying to do this, the first thing that I might do is just literally draw a line, but I know that I'm going to need some kind of toothpick object. This is a good case of object-oriented programming because I need to create a class that describes what it means to be a toothpick. What does it mean to be a toothpick? Then I can have an array of many toothpicks. Okay, so that's not going to work. New tab, call it toothpick. I'm going to say class toothpick. And what do I need in a toothpick? So I know that I need a toothpick. I need to have two endpoints. What's the XY location here and what's the XY location here? So I'm going to call those AX, AY, BX, BY. And I'm going to write the constructor. And the way that I'm going to do this, the way that I think is going to work the best, like when I create a toothpick, what I'm going to do, the toothpicks can only be horizontal or vertical. So I'm going to create a toothpick by giving it the center point and then giving it a value like 1 or -1, whether it's horizontal or vertical. So in addition, it is also going to, each toothpick will have a variable called dir for direction or orientation. So I'm going to give each toothpick an x, and I'm using integers very specifically because I think this is going to make my life easier to sort of almost think of this toothpick as living on a grid, and you can't have spot 1.37 or 2. I really want to be as close to pixel perfect as I can. So, and I also, this is really a global variable for the whole system. I'm just going to make a variable called length for how long a toothpick is. And I do want an odd number because I want to be able to have that center point be perfectly, have each half of the toothpick be equal in size. So for example, if I had a toothpick of length 9, then the center point is at 5. No, 4. 0, 1, 2, 3, 5, 6, 7, 8. No, wait. You get... Matthew, you'll edit this, right? Hold on. Let me explain why this is important. If I have something of length 3, right? This is the total length of this is 3. This is the center. I have one spot here and one spot here. If I have something that's of length 5, then I've got 2 here, and a perfect center. So this is going to be important in terms of, I think, the sort of evenness of how I place the toothpicks. And we could probably make a different set of code that accounts for that, but it's going to make my life easier. Toothpicks. Wait, there's a toothpick stuck in my computer. Okay, hold on. I'm going to get it out. Toothpick. No, there we go. Okay. All right, so length, let's just start with a length of 9. And what I'm going to say is that, and I'm going to get a direction. So I'm going to say that if the direction, so first I'm going to say that, and let's just call this D. Direction equals D. If the direction equals 1, let's make that a horizontal toothpick. So then AX should equal X plus length divided by 2, and and BX should equal, so AX should be X minus length divided by 2, and BX should be X plus length divided by 2. And then the Y's are the same. AY is Y and BY is Y. And then let's make a toothpick that is vertical. So I'm going to do all the same stuff, but these are now going to be with the Y, higher and lower. And let's get rid of this white space here. And so now, then I'm going to write a function called like show. And I'm going to say, I'm going to say stroke 0. So let's make it a stroke weight like 2, just so we can see it. And then I'm going to say line from AX, AY to BX, BY. So this is the idea of a toothpick. A toothpick has 2 points, A and B, AX, Y, AY, AX, AY, BX, BY, and it has a direction. Just to be clear about this, because this is so fundamental, this is the toothpick. This is point AX, AY. This is point BX, BY. But also the toothpick could be in this orientation as well. Okay, so now in my main program, I'm going to make I know I'm going to need to have a list of toothpicks. So I'm going to make an array list full of toothpicks. Let's call that picks equals new array list toothpick. Now, if you're coming from all of my JavaScript video tutorials, this is a pretty weird thing that I've written. Because in essence, if I were doing this in JavaScript, why does it not know errors? Wait, what did I do wrong? Time out for a second. Wait a sec. What did I do wrong here? Oh, toothpick capital P. Also, does this code a good size? And I think it needs to move over a little bit. Silly me, I have a capital P there for no reason. So what I was saying was, if you've come from my JavaScript videos, you would see me do something like this. Like making an empty array that I'm going to fill in JavaScript is super simple. In Java, which processing is built on top of, I've got to use this data structure called an array list. I don't have to. There's other data structures which I need to specify what's going in it, toothpick objects, and then I need to create it. So, so there. Now what I want to do is I want to say picks add a new toothpick, which I'm going to put at 300, 300. And you know what? I'm going to put it at 0, 0. And I'm going to give it a direction of 1. Because what I'm going to do here is I'm going to say translate width divided by 2. I'm always going to think of the center at the center of the canvas as 0, 0. So I need to translate to that center. And then I'm going to say for every toothpick, T in picks, T.show. So this is now a loop where I'm just going to say whatever toothpicks I have. So I'm starting with one toothpick. I made a class, object-oriented class, a template for a toothpick. Then I made an actual toothpick, 0, 0. I can't remember. One is either this way or this way. And then I'm saying whatever toothpicks I have, show them all. And so now if I were to run this again, we can see there's my toothpick. And let's make the length, let's have length be kind of like a global variable over here. And let's have that be something more like 63. And let's run this again. We can see there's my toothpick. And by the way, I could do something like this. I mean, as an exercise, I could just make a ton of random toothpicks. But that's not what I want to do. What I want to do is each cycle, right? I want to say, what are all the existing toothpicks? Check every existing toothpick, look at its endpoints. Or is that a free endpoint? And if there is, make a new toothpick there. So a nice way to do that in the draw loop is to start by actually saying, make another empty array list. I'm going to call it next. So this is kind of like the next generation of toothpicks is another new, boy, there's a lot of typing going on here with these array lists. I'm going to make a new list of toothpicks, the next list. And as I go through all of these existing toothpicks, what I want to say is, I'm going to say, you know what I'm going to do? I'm going to ask the toothpick to create. I'm going to say call create. I'm going to name these create A, create B. There's probably a better name for that. I'm trying to think. But what I mean is, let's have the toothpick itself. It knows about its edges. Maybe I need to, when I call those functions, pass in an array to all of the existing toothpicks. Like, hey, check yourself before you wreck yourself. No, check yourself against all the other toothpicks to see if your edges are touching any of them. And if not, make a new toothpick. And these should be, and then I should say toothpick. This function should return two new toothpicks. I'm going to call them A and B. I should probably call them, if I'm being consistent here, like next A and next B. So right, and then, okay. So what if, then what I think I'll do is I'll have this function. I'm kind of planning this out as I'm going. This might be a bad idea. We'll find out. I'm going to have the function, if the endpoint is not actually free, just return null. So it will return a new toothpick if it's a valid endpoint edge. If it's not, it'll just return null. So what I'll say here is if next A is not equal to null, then next.add next A. And there's probably a way I could do this with one function or something. And if next B is not null, add next B. And then at the end, what do I want to do? I want to say, I think, toothpicks.add all next. So I think this is the idea. Like, I haven't really written the code for doing this yet, but this is the idea. For every existing toothpick, and here's the thing, I don't want, this would be problematic if I didn't, I think there's a couple reasons why I want this next array list, and I did sort of think about this in advance. Like, you might be thinking, why not just add them to the existing list of picks? Well, one thing is, if I add stuff to the end while I'm iterating through it, things could go pretty awry. Also, visually, what I want to do, I might want to draw the new toothpicks each time, like as a different color. There might be some, separating out what the next generation of toothpicks is from the current generation might actually be somewhat helpful. Okay, so now what I really need to do is write these create functions. So let's first write the create A function. So with this function, it gets another array list. Woo! I'll call these others and return null here. So the idea of this function is that it's going to compare this toothpicks against all the other toothpicks to see if let me say that again. So I saw a message in the chat, and maybe I did another capital P. Amr is asking, do you really need to redraw everything? You're just drawing new picks. Yeah, I could just draw the new toothpicks. The reason why I want to redraw everything is because I'm going to do the scaling thing. So sorry, I felt like I had to answer that question. Sorry, I'm getting a little bit exhausted here. It's already 12:30. Whew. All right, let me try that again. The idea of this function is I want to check this toothpick against any other existing toothpicks to see if they're sitting on the edge. And if they're not, I'm going to create a new toothpick on the edge. So here's how I'm going to do that. I'm going to say for every toothpick other in others, oh jeez. If, and let's try, oh, this is hard. So I'm going to write some pseudocode for a second. If this pick is touching other, and first I want to say, actually, by the way, if other is not equal to this, like I only want to check, like I don't want to check this if this toothpick against itself. And I'm going to say, oh, this is Boolean available. So I'm going to assume the toothpick is available. So, and then I'm going to loop through all of them. And if I find that its edge is touching any other edge, then it's not going to be available. So how am I going to do that? So let's write a separate function. Oh. How am I going to do that? Let's write a separate function, and let's just write a function called something like Boolean equal, and it takes 2 points. Can I go back and have, I need a second. My brain is like hurting me. I know I shouldn't do these new, also the chat is, I probably just shouldn't look at the chat because I've got it. I know what I'm doing here. And it's not, you'll see that it's not n squared. All right. Mathieu, I'm going to go back to where I was writing this function. All right, so I'm going to write a function that returns true or false for two arbitrary points. So what I'm going to do is equivalent, or like I'm trying to think of what I want to do here. I'm trying to decide whether I want to do this with like two objects, and maybe I should actually have a function in here like intersects another toothpick, and then I could say if other does not equal this, and this does not intersect, and this intersects other. Yeah, let's do that. Okay. Sorry, Mathieu, I'm making this editing complicated. Yes, and Aaron is saying check only the newly added toothpicks. that's going to be a really important optimization. So I will do that. But I haven't gotten there yet. Okay. So first, I think what would be helpful here is, in addition to checking to make, what I want to say is, as long as the other toothpick is not this toothpick, and the other toothpick, I'm going to say touches this toothpick, then available is false. So it's not available. So this is not an available spot. So now I need to write a function that one toothpick can check against the other one. And I'm going to write that in here. I'm going to say Boolean touches another toothpick. And basically, like, how do I know if, I basically want to check to see if two endpoints are the same. And because I used integers, I can actually check for equality here. I don't have to do like a distance thing. So I can actually just say if other.ax equals this.ax and other.ay equals this.ay, return true. I could write this as one statement, but I'm just going to do it this way for a second. And then let's check the b values. Oh, boy, there's 4 possibilities here, though. Oh, I'm making this so silly. This is one of the silliest functions I've ever written. Because there's 4 possible, right? Because then A could also equal B, and B could also equal A. And these should, right? So AX equals AX, AY equals AY, BX equals BX, BY equals BY equals BY, AX equals, oh boy. This is getting really bad. This is getting really bad. Let's go over here for a second, right? I have 2 points. AX, I have A1 and B1. Oh, this camera's off. Let's take a minute to actually really figure out what's going on here, right? Because I have, with 2 toothpicks, I have A1 and I have B1, and I have A2 and I have B2. So I want to make sure, so I have 4 points. I want to make sure that A1 and A2 are not the same, that A1 and B2 are not the same. I want to make sure that B1 and A2 are not the same, and that B1 and B2 are not the same. So yes, there are 4 possibilities here, and if any of those are the same, and by the way, A could be this, 1 could be this, and other could be 2, right? It's not 1 and 2 are this and other. So what I'm doing is checking to see if other A is equal to this A, or if other A is equal to this B, or if other B is equal to this A, and if other B is equal to this B. This is really right. This is so insane. I'm really doing a horrible job at this. Return, and then if none of those are true, we're going to return null. Oh, I should be taken to the coding sanatorium, right? If none of these are true, return null. Why? What error could you possibly have to complain about? And why is, oh, I'm zoomed in. Matthew, you can edit this part out too. Other A is equal to this B. Other A is equal to this A. Other A is equal to this B. An endpoint can also touch a center. Oh, this camera went off now. Return, oh, Boolean. Yes, return false. Thank you. Oh, yeah. No, you know what? So someone in the chat is suggesting that they can also touch a center. And while that's true, I never have to check for that because I'm always placing them at the center. And so whenever I add a new toothpick, the new toothpick, its endpoints are never going to be touching another toothpick center, and I only need to check the new ones. So that's an important one. I should use vectors instead of integers. I know, right? I know. Okay. Whoops. All right, so this error is because I need to return false. And I am also getting the question about, couldn't a toothpick be touching the center? So here's the thing. There's also another really important piece of this that I kind of have in my head, but I don't think I really talked through, which is that now I need to check this toothpick. Are its endpoints free? Yes. Now I don't ever need to check this toothpick again. Once it's been added, I actually don't need to check it again. And so the idea of a toothpick touching another toothpick center is actually irrelevant. And I don't know if the touching or intersecting, these are actually going to be at exactly the same point the way that I've done the math. So I don't know, maybe I should say intersecting or touching, but I don't actually have to check this out. I don't think. We'll find out. We'll find out if I have the correct code. Okay, so now here. So now if okay. Oh, you know what? I went so off the beaten path. The way that I've written this, the way that I've written this, I'm going to go back. The way that I've written this, I wrote two functions. So this is actually irrelevant in this function because I'm checking A separately from checking B. So what I want to do, let me go back. I'm going to do this a different way. Boy, this is going to be a fun editing project. An endpoint with a toothpick. Yeah, I just want to check the endpoint. I'm actually not checking two toothpicks. I'm checking an endpoint with all the other toothpicks. I have other stuff to do today, people. I think once I get the core idea of this down, though, it's going to go really fast. All right. Yes, I'm sorry, everybody. I'm literally doing this again. Simplifying. So I don't want any of this discussion about this and other and A and B and four possibilities. No, whatever. All that is irrelevant. I'm going to do this in a different way. Is slow mode, Kate Weekman asks, is slow mode off? No, but I think it actually might be. I thought I put it on 5 seconds. Do I need to fix slow mode? This is great. It's good for me to have all these new viewers. And have it. I don't know what the F is for. Is this some kind of thing that I don't understand? Let's see. Live control room. Oh, I don't know how to find the slow mode thing. Use point objects instead of toothpick objects. F. Okay, I don't know what the F thing is. I'm gonna push forward. Okay. Now, because I've written this in kind of what is now arguably a silly, whoa, the toothpicks went flying. Somebody slow-mo that down. I don't know if you could see that. Do we have Smarter Every Day's like slow motion camera somewhere available? Okay, because I wrote this in a sort of silly way, I'm writing a create A and a create B function. What I actually just want to do here is check the A endpoint against every other toothpick to see if two toothpicks have the same endpoint as each other, to see if they're intersecting at that same endpoint. And somebody did ask about toothpicks. A toothpick, right? I'm looking for the case where this is toothpick 1 and this is toothpick 2, and this is like point A, and maybe it's the same as point A or B of another toothpick. This is what I'm looking for. But it is the case that toothpicks could also be intersecting the center of another toothpick. but I'm pretty sure I don't have to check for that because once I add a toothpick, if I add 2 more toothpicks, sure, this toothpick is intersecting here at the center of these 2 toothpicks, but it's done. Like I never have to check this toothpick again. Once I have added something to that toothpick, I can call it quits and only check the endpoints of these new toothpicks. And by definition, there could only be, the way this algorithm works out is, these the 2 toothpicks here are intersecting at the endpoint. So I'm pretty sure that's how it's going to work. If you look at the demos of it and how it works, I don't think I need to check the center. Okay, at least I'm trying to convince myself. So as long as it's not the same toothpick and intersects, I'm going to write this rather awkwardly. I'm going to say intersects AX, AY with other, then available is false. And so maybe what I want to do is say like other dot intersects AX, AY. So this is actually like available equals false. So maybe this is kind of like a function inside of the toothpick class that it can check if it's intersecting any generic point. So this is a little bit confusing what I'm doing, but I'm going to write a Boolean function that says intersects any arbitrary x, y. And I can say basically if ax equals x and ay equals y, that is a case where I should return true. Otherwise, if bx equals x, I'm just checking both points, and again, easily, there's probably a better way to do this. I'm also going to return true, otherwise return false. So basically, this is the idea, and these are integers. And I can check for equality here because I'm doing all integer math. If I had used p-vectors and floating points, I'd be worried about, I have to use the distance or something. But as long as the a point and the b point of this toothpick is not equal to this arbitrary x and y point, then I want to return false. So now, here comes the fun part, right? This fun, I'm having fun. Weeping emoji. If it's still available, then what I want to do is return a new toothpick. And the new toothpick center is where? It's at that point. So the new toothpick is at AX, AY, and its direction is what? Its direction is always the inverse. So if this one's 1, this one's -1. If this one's -1, this one's 1. So it's just direction times -1. Otherwise, return null. Okay? So now we're going to go back here. Let's forget about next B. Let's forget about create B. I also want to do something. I'm going to say no loop. I want to control the looping. And then I'm going to add mouse pressed. And in mouse pressed, I'm going to call redraw. This is so I can click the mouse through every frame. So let's see if this works. Let's see if I can kind of condense the code a little bit so we can look at more of it at once. And now, oops. If other does not equal this and other, I'm missing a parentheses there. Let's go back here. Let's run this. Okay. So now, if I click, I got a new toothpick. I got a new toothpick, new toothpick, new toothpick. So this is actually working, but it's just doing that one endpoint. So again, I really shouldn't, there's no reason for me to have 2 separate functions here, but why not? What I'm going to do now is in the toothpick, I'm going to just, this is terrible. I do not like this at all. Do not like copy pasting. I'm going to just call this create B. I'm going to say bx, by, and bx, by. So this is exactly the same function, but checking the B endpoint. And I can do this because a toothpick only has 2 endpoints. But this doesn't scale. You can't generalize this to any kind of shape with any n number of endpoints. So definitely going to have to rethink this for maybe a future video I might make. Whoa, look at that. That kind of looks like the toothpick pattern. So in some sense, we're done. But a couple things I want to do. Number one is I would like to, there's a big optimization I can make here, which is to only check the new toothpicks. So one thing that I'm going to do is, let's make these two different loops just to, let's separate out the drawing from the picking the next stuff. The other thing I should do is when a toothpick is a new toothpick, so let's call it new pick, oh that's weird, is true. So, and then what I want to do here is when I draw it, let's just try this for a second. If it's a new pick, say stroke, let's make it blue. And then, by definition, then new pick would be false. So I just want to, and actually let me not do that here. So this should be, now they're all blue. Okay, so they're all blue. When all the new toothpicks are blue. And then what I want to do here is I would say if T is a new pick, again, I could probably keep it in a separate list, but whatever. If T is a new pick, and then I can do all this checking and then say it's not a new pick anymore. All right, so this is going to limit all of the checking to only the toothpicks that were actually new the previous time. And I could keep the next array list from one cycle to the other, but this I think will do the trick right now. Blue, you can see this one is no longer blue, only these are blue, only these are blue. So in theory, I have now optimized this a bit faster. Okay, so now going back to the code, I can, to get rid of this no loop, I can let it just go on its own. And we can see it sort of filled up the screen really quickly. So this is what I want to do here. I want to use the scale function to, as it grows, sort of zoom out on the drawing. So scale is a transformation that can scale what I'm seeing. So for example, if in the draw loop here, I just say scale 0.5, you can see there it is at half the size. If I say scale 0.1, we can see all those toothpicks being added at a much lower scale. Okay, so how do I have that dynamic? So the way to have that dynamic is, one way would be, let's try to figure out maybe what toothpick is furthest to the left edge and furthest to the right edge. So what if I have some global variables like min x, which is equal to 0, and max x, which is equal to width. Oh, and actually these should be negative. So because I am considering this around 0, min x would be negative width divided by 2. Max x would be positive width divided by 2. So negative 300. That's the sort of the minimum and maximum range to start. So I could say the difference is the scale, the scale that I want, let's call that like a factor, is the maximum x minus the minimum x divided by the width, right? Or actually the width divided by that, right? Because if the distance between the furthest toothpick to one side and the furthest toothpick to the other side is twice as long as the actual width of the window, then I want to scale it to 0.5. So, but of course I need to find out these maximum and minimums. So the way I can do that is I can actually just, right here, since I'm looping through all the picks, and in theory, like I'm going to get the scale for the next round, but that's fine. Min x is the minimum, whichever is smaller between the current picks is, let's just use one endpoint. I mean, I could probably check both endpoints, but let's just make sure this works. And the current min value. And the maximum is whatever is the biggest between ax and max x, right? I think this should work. Factor is, what did I get? Did I get like a, The value of the local variable factor is not used. Well, sure. Oh, scale factor. But that's not the error I'm getting. But divide by 0. Max x minus min x. Oh. Whichever one's bigger? Oh, no. This has to be max x. Oy. Oy! I had that wrong for a while there. Okay. Yep. Oh, you know what? Are these are all integers. These are all integers. So integer math is going to give me 0. There we go. Okay. So now I am scaling according to, and you know what I should do? These are getting, I'm scaling according to the distance between the sort of like furthest toothpick and the furthest toothpick along the x-axis. I could do this along the y-axis. There's probably a lot of smarter ways to do this, but this will work right now. So the other thing that I might like to do is calculate this factor. I should probably store this as a global variable also because I kind of want to use it. And you know what I could actually do? I could just do this. I could pass it in here because what I want is also the stroke weight to be maybe inversely proportional to the factor. So like as the factor is getting smaller, I want the lines to be thicker so that maybe they show up better. Yeah, I don't know if this is really reading, but like as they're shrinking, the lines are getting thicker. Goodbye, YouTube compression algorithm. But you can see the idea here. So it's going to run really slow. I have not super optimized this, but what would be fun to try is, and maybe I should just make them a little bit thicker, like 2 times that. What would be fun to try, what I would like to do, is to see if I can make a nice full screen version of this. In P2D, will that help? So here we go. Here is I'm sure the YouTube compression algorithm is making this impossible to watch, but here is the toothpick number series from the number file channel visualized using Java in processing. Now it's running super slow. What I want to do, but I should check the number series. So let's actually check that number series. Let's do print, one more time, print line. What do I want to do? I want to check how many toothpicks there are, picks.size. And let's change the frame rate to 1. And let's open up the console. Let's put it back to a smaller size. And let's open up the console so I can see this better. All right, so here we go. 1, 3, 7, 11, 15, 23, 35, 43, 47, 55, 67, 79, 95, 123. Is this right? I really hope this is right. Let's check. If I hit stop, will it stay? Yes. Okay. Let's go back to that number sequence site. Cross-check this. I didn't use 0. 1, 3, 7, 11, 15, 23, 35, 43, 47, 55, 67. Thank you. Woohoo, it worked. So by the way, you should watch that number file video. You should look at these. You should try. There are so many other ones, and there's different shapes. Toothpick on a hexagon. Wow. Whoa. A reset, reset, reset. Look at this. Oh, no, wait, hold on. Reset, reset. Toothpick on a hexagon. Oh, boy. Woo. So there's so many interesting possibilities here of things you could try. Let's look at, there's one that's like a nice maybe it's the E toothpick that's kind of like snowflake-like. Yeah, look at this one. Oh, that is so, I really want to do. So maybe next week for my holiday special, I'll try to do this one. But you should explore all these. Watch the number file video, expand this, refactor the code, make your own version. I will release a version of this that also runs in JavaScript, that you can do that to run in the web browser. So you can check this video's description and share with me your variations in color and animation and how you think about doing this. I can't wait to see what creative stuff you make. Okay, goodbye. Okay, this has been a 2.5-hour live stream. It's 1 o'clock. And I'm looking at my email, which I should not be doing. Time to unbox. Use a mapped. Amr is saying, use a map data structure where the key is the endpoints and the value is the number of toothpicks touching it. Oh, interesting. That's a great idea. Don't forget to scale against height. You know. Aaron is saying you're still checking every newly toothpick against all of them. I am, but I don't know what's an optimization around that. Like, which ones can I skip? Am I just checking like the last round? Oh, am I only checking the new ones against also the new ones? No. Hold on. Let's look at this. Oops. Right? So the next toothpicks, clearly they're intersecting against the toothpicks from their current round. Same here. But these toothpicks hit the endpoint of this toothpick, which is from a previous round. So I think I do have to check. I think I have to check. I can't just check the new toothpicks against other new toothpicks. Yeah. So I'm not sure. Thank you, Graven Development. This.channel.donate. That's cute. I love that. Why is this really showing up? Time to unbox that uke. Yeah. I did say I was going to do that. I definitely can't do any coding. I am done coding. I am actually recording this to disk. Amazing. Let me just so I make sure it captures. For once I remembered. Color the toothpicks based on their XY mapping between 0 and 360 for hue. That way you get a rainbow. You should do that, Swirl Studios, and then submit it. All right. You asked for it. You're getting it. Overhead camera. Not a sponsor. Buzz marketing this ukulele company. Ooh. Here we go. So the previous ukulele was a very inexpensive ukulele that was less than $30. This is a bit more, this is not a super expensive one, but it should be a bit nicer with nicer strings. It's also concert size, so it's a little bit bigger instead of soprano, so I can play some holiday coding songs on it next week. And it comes with some accessories, like a tuner, which I'm definitely going to need right now. A strap? Ooh, there's actually a strap? How interesting. I wanted to find a rainbow ukulele, but all of the ukuleles that had crazy weird patterns on them seem to not be of high quality. If I put a sticker on this ukulele, is that going to cause a problem? And then this, in theory, is the strap. Do I unscrew this? I am so mechanically challenged. How do I attach this to that? Maybe I don't need to worry about the strap right now. But there are these two, right? The strap goes on these things. Okay, so that's the strap. What else do I have? I have some sort of, like a pick case and a pick. I've never used a pick with a ukulele. By the way, I am not a musician. And I have extra strings. Please read other side before contacting or returning the ukulele. Please do not return it to the retailer. Okay. All right, so there's some nice information. This is a tuner. A, C, E, G, right? Do I need I might need a battery for this. Shoot. You may need to flip the battery around. Okay. Oh, there's a battery in here. There's 2 batteries. Wow, they really thought of everything. Except for the fact that I am completely mechanically challenged. Push the metal through the strap hole and it should stay. So which way does this go? One side is the positive side. This is the positive side. Positive side goes which way? Negative side, does it say here? Well, we'll just try it one way. Let's try it this way. This is my best guess. Very little chance this is right. You know what? Yeah, this has got to be this way, right? It's got to click on in there. There we go. Okay, maybe that's not right. Oh, good thing I have all these toothpicks. Must be the other way. Yep, now the tuner is on. And this one's C. Ace. This should be G. I still want to do that coding challenge. A, C, wait. Ukulele tune. Right, A. Oh, this is A. Yeah, what am I doing? Yeah, sorry everybody. It's a nice A for you. Somebody in the chat sent me AE. A C. I had this at C. Sorry, out of tune. All right, so this is ready for, I gotta tune it a bunch of times. Hopefully it will hold its tune fairly reasonably. But this will be ready for next week. So send me your, I've got 21, I should get rid of this here, 21 Christmas songs. I suppose I could try to learn some Hanukkah songs or some other holiday songs for other holidays around this time of year. Some of them are easy. They're like 2 chords. Like Jingle Bells is probably 3 chords, right? Let's find that. Any song that I have in this book, you can send me new lyrics. Right, so that was pretty easy, Jingle Bells. So in order to solicit your donations, I will be making a fool of myself and embarrassing myself next Thursday playing coding-themed holiday music on this ukulele while on a live internet stream. So thank you all for tuning in. Thank you for watching The Coding Train. This has been a lot of fun. I don't know, I feel like the Fourier thing worked out pretty well, but it was kind of long. The toothpick thing was kind of a mess. I don't know. Unknown Gamer asks, is it hard to learn ukulele in comparison to guitar or easier? I would guess easier because I started trying to teach myself the ukulele like 3 months ago, something like that. Somebody find when I first did it in a coding train. I can play the piano a little bit, not well. But, what was it? When I get old, I'll Okay, I am exhausted. I'm going to go have some lunch, answer all my emails. Thank you everybody for tuning in. Welcome new viewers. If today was the first time you watched, thank you. If today was like the 100th time you've watched, thank you. I would love to hear any feedback. You can let me know on Twitter. Yay! Yay! I'm going to clean up all these toothpicks later. Oh my God. And I will see you all in a future Coding Train episode. So also, if you don't know, I will make edited versions of these 2 coding challenges. They'll come out sometime next week. I have toothpick balls going down my shirt now. And I will see you later. Mwah, mwah. Thank you for watching. This has been wonderful. I've really enjoyed being with you today. And I am going to click the stop streaming button. Oh no, it's over here. Someday I'll have an outro coming soon, someday. And here we go. Hi, Naso. Sorry you just joined. As soon as I stop this, you'll be able to watch the whole thing back if you feel so inclined.